I understand you can just get on your calculator. I understand you could have had the answer 2 minutes ago. But as a student going on and doing more math, for those of you who need more math, your understanding of it is more important than just getting an answer on a calculator, because these connections are going to just follow you. And the more you're comfortable with this, the easier it's going to be to proceed through your math courses. All right? Any questions? We're not done. We're going to get an answer here. Any questions? 1 minus 2 times, now this just became pi over 4. I'm not going to use 45 degrees. And the reason I'm not doing 45 degrees is because these numbers are not in degrees. So I'm not going to throw a degree in here all of a sudden. I'm going to use the radian instead. And 1 minus just pi over 2, because the 2 and the 4 reduce out like that. And then for that, I might need a calculator. For now, I'm just going to box it up. This is what I get when I plug 1 into this function, right? When I plug in 1, I get this number. And I believe this can be a negative number, a negative answer. Well, I know it is, but if you check on your calculator, that's going to be a negative. Okay, good. Are we done? Are we done with the problem?
No.
No. All I've done is the first step. I found the critical numbers. I plugged those numbers into the original function. I only had one critical number. I just plugged it into the function. Now what I need to do is plug in the endpoints, right? All right, so now this is step 2. I take the original function, I plug in 0, and then I take the original function, I plug in 4. Okay, so for 0 into the original function, I get 0 minus 2 times tangent inverse of 0. Let's do that one. So without the calculator, this is saying at what angle is your y-coordinate divided by your x-coordinate equal to 0? So where on the unit circle is your, and you can't look over here, between here and here, is your y-coordinate divided by your x-coordinate equal to 0? Well, that would mean your y-coordinate has to be 0, right? The only way that fraction can be 0 is if the top is 0. So that means your y-coordinate would have to be 0, which means you'd have to be here, wouldn't, right? And what angle is that? 0, right? 0. So this is 0. Gone. So the final answer here is 0. Okay. This one, 4 minus 2 times tangent inverse of 4. Now, in the thank you. So in the previous two, when we needed to do tangent inverse, I went to the unit circle because I know tangent inverse of 0. I knew what tangent inverse of 1 was just by the unit circle. But tangent inverse of 4, I'm not going to be able to find easily on the unit circle. So this is where a calculator would be useful. So on your calculator, make sure you are in what mode? Radian mode. Do inverse tangent of 4. On an exam, okay, on a test, if you use your calculator for this whole problem, I'm not going to take off for that. You can get the answer using your calculator. I'm advising you as a student who's going to pursue more math that you understand the inverse tangent function in terms of this unit circle, just to be a more solid math student, all right? You don't want to, if I say right here, if I put on the board 7 plus 3, right? I'm kind of insulting your intelligence here if I say, hey, what's 7 plus 3, right? It's yeah, I know what that is, right? So if you're in a differential equations class, right? Because you're an engineering major, and you're in differential equations class, and someone puts, someone's trying to solve this, inverse tangent of 1, and you break your calculator out, that's like you breaking your calculator out for this. That's what it seems like for an engineer. You should know what this is without needing a calculator for it, because you understand what it means. Does that make sense to y'all? Okay, I'm trying to help you, all right? What are we doing? I forgot what I'm doing. Oh yeah, you were doing. What did it come out to be on your calculator? This right here. 1.326, okay, close enough, we'll round. And then now, let's do this whole thing on your calculator. 4 minus 2 times 1, what do y'all get there? 1.348, anyone else get that? Anyone else? Yes? Okay, now I'm not sure, can someone do this one as well? 1 minus pi over 2. 0.57. Okay, there we go. All right, that's step 2. Yeah, go ahead.
For that one, do
Yeah.
you want us to get to the decimal, or would you accept 1 minus pi over 2?
This is the exact answer. This is a better answer. This was just to help show everyone that this is a negative number. It's hard for some people to realize that's a negative number, but it is, right? So it's easy if I look at this to be able to tell which is the max and the min. So what is the max, the absolute maximum value of this function? 1.348. That's the max, right? And the minimum is that one right there. So again, if I go to Desmos, right, and I graph this, I should have just kept that there. It was x minus 2 arctangent of x, but we're restricting it between 0, 4. All right, so there it is. There's the graph, restricted. And do y'all see that at an x value of 1 here, that's 1 right there? You see we have our minimum there? That's that number. And then the max occurred right here at 4. We had our right endpoint give us a maximum of 1.348. Okay, I think we're done. Do we need another one? Do we need another example? The problem with this idea is that every function can be different, right? So the work required to set it equal to 0 and figure out where it's undefined is going to be unique to the problem. And so now you have to try a variety of problems. I can show you 20 problems, and then the 21st problem I show you is different. So you're never going to be able to do like enough problems to be completely comfortable with this. So that's why I recommend that you work through the homework assignment, all right? Yes?
So can we only get the maximum in the second step?
Can you?
Find one of the answers to the first step.
I'm not sure I understand your question. Can we only find the max and min?
From the second step when we plug in
The 2 endpoints?
yes.
Yeah?
Okay. So what I'm trying to say is like
I think he's trying to ask if you can skip one of the steps.
no, that's
No.
like because like in this problem we got the maximum. Actually, no, never mind.
You sure?
Yeah.
Okay, if you think through it and it's clear out of your mind, you can ask again. Yes?
Can we do another one where we're using multiplication, like, or division with the inverse of a trig function?
Where we do division?
Like the original function has like another inverse function, preferably one with division, so it's a little bit more.
I have to be careful that I give you something you can that works. I can't. So like if I ask you to take derivative of a function, I can pretty much make up anything and we can take the derivative. Setting it equal to 0 and solving it is a different story. I can't just make up anything because we may not be able to solve it with the skills we have in this class. So I have to be careful. And I don't want to go outside the scope of what I would ask on a test either, right? So let me stay within the scope of what I'd ask. I would never give you a trig function, an inverse trig function inside of a fraction on a test. I wouldn't do that. I would, however, let's do one more. I like to go to the chapter review sometimes because the chapter review will have some problems that are kind of different. No, I don't like those. Okay, let's do this one. So back when I was a calculus student, right, I couldn't do this, right? This was not a possibility here to just go to Google and then do what? What are we doing right now? Absolute, max, min, closed interval, examples. I'm just trying to imagine if I was a student right now. Like this is like, I can't believe this is a resource y'all have. Like, it's crazy. I'm not trying to go get answers to cheat on a test. I want some examples to practice. So let's see. Khan Academy is not bad. Steps to find absolute, UT Austin, that's I think that's credible. Let me see. I just want examples. No. Product quotient rule, chain rule. Relate. Absolute, okay. Any examples here? I didn't see examples. Oh, there we go. Hey, there's an example. Right there. Let's use that one. All right? Two x over x squared minus 2x plus 2. So I'm aging myself here, but when I was a student, I had a recorder, a voice recorder, right? That I'd bring to class, I'd set on my desk. I had to ask permission from the professor if I could have it, right? And I'd record my lecture, record his lectures or her lectures, right? And then that way I could go back and play it and listen to it, right? And listen, and that's the only resource I had, right? That's it, that and my notes. There were no websites with anything or, yeah. Oh, 03, I think, right? Was it 03? Yeah, 03. Sorry, I just hadn't finished writing it up here. 03. All right. Derivative, yeah? Derivative. So I've never done this problem, right? I've never done this problem. So let's see what happens. First step, let me take the derivative of this. All right, so if I take derivative, it's going to require quotient rule, right? So derivative of the top times the bottom minus derivative, blah, blah, blah. Okay, derivative of the top is 2 times the bottom. Minus. The derivative of the bottom is what? 2x minus 2. And then what next to it? Times 2x. Hold on. Hold on. Parentheses around this. You have to have parentheses around that derivative because you're going to multiply by 2x, right? That 2x must go through to both of those. That's why I took off on tests that you've taken, I've taken off when you leave those out, because if you miss that now, you're never going to be able to set this equal to 0 because you're not going to have the right equation, right? So that's the derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom, squared. Okay. Raw derivative. I need to set that equal to 0. So let me start cleaning up the numerator. I'm going to pass this 2 through. And here, I'm going to pass this 2x through like that. So my next line will be 2x squared minus 4x plus 4. And then minus, in parentheses still, 4x squared minus 4x. So I just multiplied here and here. Kept the minus out front. This on the bottom, I'm not going to square. Why do you think I'm not going to square that? Because I don't feel like it, or? I'm going to want to know when this fraction is 0, right? So do I really care about the denominator? No. So I'm just going to leave it alone. I'm not going to touch it. Keep cleaning up. 2x squared minus 4x plus 4. Distribute the negative through. Minus 4x squared plus 4x all over, yep, all that. The denominator squared. And then I can clean this up. There's some good things that happen here. The negative 4x and positive 4x cancel out. Then I have a 2x squared and then minus 4x squared, right? How many x squareds is that? Negative 2x squared. So I have negative 2x squared, and then I still have a plus 4 up there, don't I? All over x squared minus 2x plus 2, that quantity squared. All right, that's a pretty good looking derivative, right? Like I've cleaned that up pretty nice. I'm going to box this up. I like it. I don't think there's anything else I want to do with that. I'm already thinking if I have to set the numerator equal to 0, I think I'll be okay. All right, so I'm going to now figure out where the derivative is 0. So my derivative being 0 means when is that equal to 0? So that all I have to do there is just set the top to 0. I'm skipping the step of writing the whole derivative out. I'm just going straight to setting the top of it equal to 0. And again, we have another quadratic equation, right? I'm going to go to that technique again where I get my x squared by itself. So I'm adding 2x squared to both sides. I'm dividing both sides by 2. And then I'm taking the root, and I get plus or minus root 2. Right? Follow? Keep them both, throw them both away, keep one. What am I doing with those? Getting rid of the negative. Because my interval's from 0 to 3, so anything negative I'm throwing away. So actually, it's x equals positive root 2. There we go. I have one critical number so far, right? So far. Y'all good? Yeah? Okay. What do I need to look at next? What's that? Where the derivative doesn't exist. And shit, I just erased the derivative. Okay. The derivative doesn't exist, right? That's the question. The derivative was negative 2x squared plus 4 over x squared minus 2x plus 2, that quantity squared. That was the derivative, right? That was the derivative. I'm only concerned about where this thing would have a problem, which would be where this denominator is 0, right? Anytime this denominator is 0. So let's say I found a number that made this 0. X equals, let's just say I found some number, right? X is some number and it made that 0. That'd be a critical number, right? But do y'all see that whatever that is, that's not in the domain of this function? I mean, like, look, you have the same denominator here as you have here. The only difference is this one's squared and that one's not. So any numbers that mess that up are going to mess that up. So I don't need to check anything because it's already implied that numbers in here don't mess that up. Right? Or else I wouldn't be able to give you that interval because there would be places where it's undefined. So there's nothing for me to check. Now, if you really wanted to, though, if you really wanted to, ask yourself when this is 0, right? If you wanted to know when it's 0, then you could just solve that, couldn't you, using quadratic formula? You could. I'll do it real fast. The solutions to this are x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, okay? That's quadratic formula being applied to this. And you'll notice that underneath the root here, I wind up getting 4 minus 8. And 4 minus 8 is a negative number, and the square root of a negative number is an imaginary number, which means this has no real solutions, which means this is never going to be 0 anyway, because there's no numbers that ever make it 0, right? So I'm safe to move on, right? Because this is never going to happen. Now, what if this would have given you 2 answers? Like, what if this would have not been a negative under here? Like, let's say it was, let's just say it was plus. Then I'd have 2 answers, wouldn't I? I would just check and see if they're in that interval. And I can guarantee you they wouldn't be in the interval because they wouldn't have never given you a problem where you had a problem within that interval to begin with. So, all right. Where am I? Oh, I'm still in step 1. I need to evaluate the original function at the square root of 2, right? That's what I do. Take that answer, root 2, plug it into the original function. All right, square root of 2. So 2 root 2 over root 2 squared minus 2 times root 2 plus 2. All right, that's what I'm doing. So this is 2 root 2 over square root of 2 squared is just 2 minus 2 root 2 plus 2. Did y'all hear that? It's like a real high-pitched. Did it just start? I'm just hearing it now, right now. No? It's been there for a while? All semester, probably. How about this? What'd I do there? Yeah, every single term, every one of these has a 2 in it, right? So I just basically killed off a 2 from all of them. Oops. Sorry. Nobody ever calls me this early. All right, and now, I don't know, this is root 2 over 2 minus root 2. I'll get that as an answer later. All I did there was added the ones together, 1 plus 1. I'll get the answer later to figure out what it is when I compare it to the endpoints. Can we do the endpoints now? Step 2? So for step 2, I take the left endpoint 0, plug it in, I plug in the right endpoint 3. If I plug in 0, life is good, right? Because what do you get on top? 0. And on the bottom, are you going to get 0? No, you know you're never going to get 0 on the bottom because we did the quadratic formula, remember? And it said that we could never get 0 down there. So this is 0. And then if we plug in 3, well, let me just plug in 3. We get 6 over 9 minus 6 plus 2. This is 6 over 9 minus 6, 3. 6/5. I'm moving fast through that. 6 over 5. So I have 3 answers here. 0, 6/5, and then this right here. And this, if you do this on your calculator, you will get, no, it's not negative, it's positive. I need to know what it is then. Darn it. So if somebody could, please. 2.414, anyone else get that? Is it, really? Yeah. Anyone else get that? Not that I don't trust you. I just don't trust you. It looks right, because this is 2 minus 1.414, which is about 0.5 something, and that's 1.4. Yeah, that seems right. Yeah, okay. So here are our answers. Max, right here. This is our max, right here. This is the biggest number I see out of these. And then our min is the 0. Shall we check? I don't know if the website had the answer. Let's go see what the website had. Oh, yeah, okay. So let's see how much work. Let's see how much work there is. Well, here's a solution. Here's the derivative. The critical values are plus or minus root 2 without any work shown. And then here are the answers. So their answer looks a little different. Do you see this? 1 plus root 2. And we got this answer? Yes? So did we mess up? We did not mess up. All it is this. If you get that on your calculator, you can get the same answer. But all they did is this, which is a common thing in algebra that they teach. It's like rationalizing the denominators. So here you'd have to multiply the top and bottom of this by what's called the conjugate. So you multiply by this. And then when you do that multiplication, you would get that 1 plus root 2. But they're both the same answer. Like this is exactly correct. This is not wrong, all right? All right, we need to move on. We have 30 minutes left. Okay, so your task now is to do your homework, all right? So I recommend, not sure what's on the calendar, but here's what I would recommend for this section. Definitely try and do 21 through 47 odds. And if you want some more practice, go do the evens. Every problem's going to be different. The algebra of every problem is slightly different.
And that's out of 4.1?
Yeah, sorry, that's 4.1. Yep. All right, we're going to move into 4.2. And we're going to start 4.2 with a question. This is going to be a question to the whole class. I want everybody to think about it, and then we're going to see if we can't come up with an answer for it, all right? And I'm going to draw a little picture to help us grasp what's going on here, all right? So we're starting 4.2. It's called mean value theorem, but here's a question. Let's say we have two cars, car A and car B, and then here's the start line. They're going to race each other, which is illegal, but we will say that they're at a legal racetrack here, okay? They're going to start racing each other. Ready? Green light, boom, they take off. They start racing, right? And they're racing, and then they come to the finish line, and here's what I'm going to tell you. At the finish line, they tie. Now, this is a theoretical problem, so I know that you might argue, well, it's impossible for them to tie because there would be a little... Let's say theoretically, they start at the same place, go, and they race each other, and at the very end, they come in tied. All right? What I'm not saying is that they go together the whole time and tie. I'm saying that, whatever happens in the middle, at the very end, they come across the finish line at the exact same time, right? Understand the question, or understand the setup? Here's the question. My question is there some speed that both cars have to achieve? So I'm saying to you, the driver of car A, right, as he's driving, looks down at the speedometer, right? And the speedometer is moving around, speeding up, slow down, whatever, right? Same with car B. My first question is there some speed that both of them will see? They will both see the same speed on their speedometers. Is there some speed that they will both see? And I'm not talking about the beginning, because at the beginning they're both at 0, right? I'm saying somewhere else in the race, like car A, maybe it's 35 miles an hour. I don't know. Somewhere on car B, will they see 35 miles an hour? Is there a speed, some speed, that they both have to see? What do y'all think? Yes? Like they both see that same speed? Do you know what it is? No? How far did they go? The same distance, right? They both travel the same distance. And how long does it take them to go that distance? The same amount of time, right? So if they both go the same distance in the same amount of time, then they both must have the same average speed. So what is the definition of speed? Maybe we should back up. What is the definition of speed? It's the distance something travels divided by the time it takes them to travel that. So if you drive 40 miles and it takes you 2 hours, your average speed was 20, what did I just say? If you go 40 miles in 2 hours, what was your average speed? Well, how far did you go? 40. How much time did it take you? 2 hours. 40 divided by 2, 20 miles per hour is your average speed. That doesn't mean you were going 20 miles an hour the whole way, right? It just means that on average, that's the speed, yes? So car A and car B both travel the same distance in the same amount of time because they tie, right? My question was, is there some speed that they both must see on their speedometers? And I'm arguing, yes, there is, their average speed. Like, let's just say that their average speed was 50 miles an hour for both of them. Let's just say. Then do you agree that some point in this race, this person has to see 50 miles per hour? Right? Is it possible to drive somewhere, to drive 50 miles in 1 hour and never go 50 miles per hour? It's impossible, right? You can't have an average speed that you never actually attain, right? And same with car B. Whatever the average speed is, car B must go its average speed at some point in the race. Do you all agree with that or not? It makes sense to everyone? Okay, my next question is different than that one, but slightly different. Is there a speed that they both must achieve at the same point in time? So is there a speed that, I'm saying the race is going on, is there some point in time in the race where they both would look at their speedometers and they would see the same speeds? Same point in time. So I want to vote on this one. Think about it and ask questions if you have them. Yes? What?
An instant, like if they both have that.
Yeah, I'm saying, I think we all agree that they both have to at least go their average speed, right? Car A at some point in the trip must go its average speed. And car B at some point in its trip must go its average speed, but they both have the same average speed.